let's look a little bit more closely at the idea of descent as applied to vector spaces and central simple algebras. Given a central simple algebra, we know that if you extend scalars to some Galois extension, you're going to split the algebra. That is, you'll have an isomorphism of this extended algebra with the endomorphisms of some vector space. And we understand that the structure of A by descent is described by looking at the structure of A tensor E and looking at the invariant elements under the action of the Galois group in its natural way. Now, this isomorphism provides, therefore, a non-standard way by which the Galois group can act on endomorphisms of V tensor E. So that is, one can transport the Galois action from here to there. This is described in terms of 1 cocycles. So that is to say, there's a standard way that the Galois group acts on the endomorphisms, and to describe this new twisted way, which I'll write with a little dot, the action of sigma, the new action of sigma on some endomorphism, is given by the class of a 1 cocycle. So we actually have to make a choice and say we should really say that alpha is a 1 cocycle. And given a 1 cocycle, we get an action via, you do the standard action on your phi, thought of as an endomorphism of V tensor E, so you act on E on the second coordinate, and then you twist it by composing that with this particular automorphism given by an element of PGL. Okay, so recall that here my vector space has itself a natural action by the Galois group by acting on the second factor, and this induces an action on the endomorphisms by kind of doing the sandwich thing. So sigma acts on phi by a sigma phi sigma inverse. As we've seen, this really just amounts to acting on the entries of a matrix by doing the Galois action on each of the entries of the matrix. So the question I'd like to ask is, given this particular semilinear action on the endomorphisms of V tensor E, described by this 1 cocycle, can we lift that to an action on V tensor E itself? So can we define some sigma dot V to be something or other, so that this dot action induces this action here, just in the same way, right? If we have some action on the vector space, then we get some new action on the endomorphisms via doing this this sandwich composition. So sigma dot of sigma dot sigma inverse of your vector, right? Well, am I doing this correctly? I guess this is a composition of dotting the vector. Okay, so can we describe the action on the endomorphisms as coming from an action on the underlying vector space? And it turns out that the obstruction to this is exactly the Brouwer group.